Welcome back to the PFC podcast. The views and opinions you are about to hear are the speakers and do not necessarily reflect those of anyone else. Now on to the podcast.
Welcome back to the PFC podcast. This is Dennis, and today we're talking confined rescue with Sean McKay. How's it going, Sean?
Doing good, Dennis. How you doing?
I'm doing well. Hey, Sean, if you would, could you please give a brief introduction about yourself, please?
Sure, you bet. I was a firefighter, paramedic on the west coast of Florida, and a team leader on a SWAT team, and kind of just specialized in rescue. I left the fire service in probably January of 2007, and since then have been doing full-time training for U.S. SOCOM and various teams within the federal government, specialized rescue teams, high-threat medical, and high-threat rescue.
Outstanding. Since we're talking about confined space rescue, I have to admit I really don't know much about it. I've never been to the ROCO course or really any other courses like it other than what I've gotten from my refresher course, so some pretty basic stuff, I think. But the way I look at the kind of the scenario of confined space rescue is you're dealing with two environments. One is either a stable environment, could be like a crevasse or a metal pipe or something like that that's not gonna move, or an unstable one such as like a building collapse. Do you think that's kind of a fair way to look at things?
Sure, you bet. When you look at it, I try and I'll preface a lot of what I'm saying to, we really have made a huge effort, and I got to throw props out to a good friend of mine who's actually through medical school now, but left USASOC a few years back and went through med school. But Jay Johnson, or I guess I should refer to him as Dr. Jay Johnson now, and his big key when we were working at redefining rescue within USASOC and in the associated group that he was with at that time was trying to delineate between rescue and medical. Very few times am I going to do a rescue where the person's extremely healthy. They either drop down or they're injured somehow. So by removing that and having separate things for medical, separate things for rescue, it causes the end user to have to try and connect the dots operationally, which can be really difficult when looking at the two if they're taught in separate things. So a lot of when we talk, we'll talk the two as if we're doing a rescue on somebody who does have some sort of pathology as far as an illness or trauma, and dealing with the environmental pathology, which is the confined space or the high angle and all. But you're exactly right. Regardless of the rescue that you do, you can have stable areas, you can have unstable areas. So your stable typically is going to be something that may be industrial, maybe being lowered in through a tripod into a pipe system where you're not having to deal with collapsed portions that are in there, where it's pretty straightforward. Move through that pipe, you package that guy, you have an artificial high directional that you move them out and kind of do that rescue. There's going to be things involved there that, even though we call it stable, that's more stable because it's stable because parts aren't collapsing in on you. It's not stable because even within confined space, you have all these other issues that can bite you in the butt, especially as far as what the air quality is in there. Is there explosive gases in there? Do I have to use some sort of ventilation to be able to put ventilation fans and things like that in there, open it up to where I don't have the kind of chemical issues that you may run into in being in a closed, confined space area with off-gassing and stuff like that. So even when we say stable, there are a lot of things that are very pathological for the rescuer and for the casualty in there. When we get into the unstable, where we're talking, we can have confined spaces when an earthquake hits or an IED hits or any kind of explosive device, hurricanes, storms, things like that, where we have building collapses. Obviously, those create small little confined spaces that those rescuers are going to have to go into, a lot of times having to create, whether it's traditional with fire trucks, where they're putting up shoring and they're building their own shoring to create stability on load-bearing walls, or you're having to do that very hastily in an operational context, which would be, kind of your U.S. SOCOM kind of group with the regardless of branch, right, from the PJs to you name it. And that can look very different across that whole spectrum of being able to stabilize a building or portions of a building to be able to go in and do hasty rescues. And in doing so, you are going through confined spaces, you're crawling through tunnels or creating your own tunnels.
when you get a call, you have no real idea of any of those things. And, maybe you have, he's in a pipe. Okay, well, it's not going to collapse on him, or it's a collapsed building. It may. Is there like a recon that happens?
There is. We've done a couple of podcasts with Andy Schrader, who's a structural engineer. He actually works with a bunch of the USAR teams down in Florida. Just an extremely talented guy. What's interesting about Andy is he's a brainiac, total nerd, right? I'll say that for him, and that way he'll listen to it, and he can come back with me on Instagram or something. But he is total nerd, watch calculator type of guy. What he does is he's basically a quick reaction force that moves towards all these buildings as quick as possible with a team, like QRF team, and doesn't touch a tool, doesn't do anything, but is very intimately involved in knowing what those rescuers have available to them and what kind of rescues and how they're going to search these buildings that have been collapsed to one level or another across that spectrum. And he takes quick notes and leaves them on scene for the guys coming in behind him to do the rescue on red flags with that building, where they should probably need to do shoring based on what kind of building construction it is, what the weight of the materials are, what floors collapsed. And off of that, he'll write his quick recommendations and what those red flags are that they need to watch out for. So as soon as they get there, they can read what he has, start executing that, and be able to make as safe of a entry or search as they possibly can based on that. But as we talk about all the time, things are non-linear and they're interdependent. So you're never potentially going to get it 100% right. So hopefully those guys that are coming in behind there, will obviously do what he asks, but at the same time keep their eye on anything that's shifting, or even in the case of an earthquake, having a secondary collapse because of other seismic activity. So
coming into doing some kind of initial recon, like, okay, generally this is the dangers. These are the dangers that are here. Like you said, you're never going to know fully until you're already inside. What other considerations do we need to take into account when we're doing a confined space rescue?
One thing I'll add on to that too is not everybody is as fortunate as some of the task force out of Florida, in that case with Andy, of having somebody that's going to come around and do that. And so having a basic understanding of just those principles, you can't ever predict everything because you're going into that area. So if you think about a team, a specialized team in SOCOM, one of the biggest things to do is everybody wants to commit into doing that rescue, but probably one of the biggest things, one of the highest principles that we always tell people is keep somebody not involved. Somebody to keep that 360 view, somebody does a whole walk around to see what exactly is going on. Everybody wants to jump in and rescue, their brothers and sisters that are in there, or any civilians or whatever the case may be. Vitally important to keep somebody that does not get the blinders on by going in and starting to initiate the rescue. There's kind of this old saying that a fire chief's a fire chief until he picks up a fire hose. Now he's a firefighter, and he loses that perspective of that 30,000 foot view, to where when you're working a structural collapse or a confined space, you need to be able to see what everybody is individually doing, because they're not always talking to each other. So if you got somebody cribbing over here but not cribbing over there, and you're getting ready to lift, that may be really bad. So keeping somebody out that just keeps eyes on what everybody's doing, asking questions, making sure that this is done, and no one lift anything until I tell you to lift, and before that lift command's given, he's able to look over and make sure somebody's cribbed or somebody's out from digging debris out from underneath one of the exposed walls or the collapsed walls is absolutely vitally important, whether you're doing rope rescue, whether you're doing confined space, structural collapse, regardless, swift water, you name it. Having somebody that maintains somewhat of a 30,000 foot view, and even if they've got to come in and help for real quick just to set something up or grab an anchor, the ability for them not to get committed into a job, to be able to withdraw and come back, even if you're in a small 4-man team, keeping one of those people out is going to add such another layer of safety and fidelity onto what's going on as a whole, because there's all these moving pieces going on in a rescue and everybody's working on something else. So that's pretty vitally important. When you look into confined space directly, one of those things that you need to be very cautious about is what the environment is when you drop down. Let's say it's into an underground pipe system or something like that, is what is that air quality? What are those risks going on? And if you're, part of a CBRN team or a dedicated confined space team, you've got monitoring equipment that you can go down. You can monitor what the air quality is, what the oxygen levels are, what all the levels are for those things, CO, those things that are going to turn out really bad for you if you don't have the appropriate PPE, whether you're rolling with a PAPRs or an SCBA, or you may not need to if it's well ventilated. So, that's probably one of the biggest parts on a confined space, a traditional kind of confined space, is understanding how to mitigate the air issues. And in some cases, you just won't be able to do it, right? And so if you're part of an ODA, or you're a small team, and whether you're an AFSOC or USASOC or you name it, and taking whatever you have available and making it, I think Herbert, back in the day, won a Nobel on his term satisficing, which is, it's kind of a combination of a couple words, but it's making do with what you have the best. And in that, even if you're able to throw a pulse ox on you, see what you are outside, start working your way in, keeping in mind anything that could throw that pulse ox off, with altitude and crap like that. But as you're moving through, see what's going on with your own oxygen saturation. And if it gets to a point where you're like, man, I'm feeling a little lightheaded and blah, 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 and you're able to look down, at that point, where you probably are going to want to pull out, get some sort of PPE, so you don't become another victim in there.
How do you prepare for just being in a confined space, having to treat it? Because I understand the medical problem, but a tourniquet, putting a tourniquet on is the same, or should be the same. But I can imagine if you're nose to nose with your patient, all these simple tasks become exponentially harder. So how do you train for that?
A lot of times, because the majority of our work with element rescue is done with US SOCOM, it does differ from traditional means in that your mindset, and we try not to complicate things. If you're learning confined space, or you're learning how to clear a building when you have no sight because part of it's on fire and things like this, you have no PPE. We try and take things that the regular operator, the regular 18 Delta, the regular SOC medic already has a good understanding of, and then places it into that context. So if you think about it, when you're in there, there's a great article, and the author's name eludes me right now, but I'll get it back to you and put it in. You can post it with your stuff. But there's some interesting stuff going on, regardless of from FEMA to USAR type teams. We have such highly trained medics now. Do we bring the ER to the medic or to the patient, or do we bring the patient to the ER? And I think the answer is very context dependent on the situation you're in. But going back to your question is you are in a care under fire type of situation when you're in that collapse, trying to put that tourniquet on. And what we usually tell people is do enough to hopefully keep them alive while you're extracting them. If you have the capability of putting in a chest tube, that may be something you want to wait. Even IVIOs extend and prolong your evacuation at an exponent. It's unbelievable. So just having to maintain a 500 bag, that's in an IV or IO around corners in that tight area is so difficult, and how you package them and what you have to maintain, let alone doing something more advanced. So if they don't absolutely need it right now, that's probably something you want to wait until you're outside of that environmental pathology, that confined space, or that collapse. Even in vertical worlds, it's very, very similar to having to package them and then be able to maintain whatever medical modality you did that wasn't necessarily necessary right then to keep them alive. And so putting a tourniquet on and things like that, it does get very, very cramped. It gets so cramped that, we kind of joke that if I'm doing a confined space rescue on you, either you, me, or both of us will be pregnant by the time we come out, because we are all up in each other's business the whole time, trying to move people around these very tight areas, and then getting to a 90-degree corner where there's not even enough room to keep your air pack on your back. You're that tight, or your PAPRs and things are getting caught up on everything. It's very claustrophobic, I guess, for some people, and it's definitely something you have to train on. There's some really good courses out there with disaster medical specialists and things like that go into that, where you may be in a partial collapse, but in a confined space, and a pipe and all that is there is your patient's arm, part of their leg, and maybe just a small little hole through concrete that you may have access to their face. And now you've got to maintain them for maybe 3 hours. So when you think about that, things get very innovative, if you will, on how you take care of that patient. So I can only access in this area. The basics become huge. Becoming a master of the basics cannot be overstated in how you maintain that patient, and it becomes very difficult. So putting yourself in those worst case scenarios is very challenging, but it also opens up a lot of new ways of doing things. We see guys be able to fabricate props really easy on that big corrugated tubing, that you can crawl through and crap like that black corrugated type stuff, where they'll punch holes in that, and they'll stick the mannequin's arm out this area, or you have access to whatever, and then being able to figure out how to put those tourniquets on here, how to put them on there, which ones work in the best situation, especially when you deal with junctional type devices, especially in collapses. It opens your eyes to a lot of things once you start thinking about it and you start working through that problem.
Okay. So, I definitely understand that there could be a controversy, like you were mentioning earlier, about bringing the ER to the patient or the patient to the ER, and that is context dependent. So, I guess if you could, let's expand on that. How, where's the decision points?
I think we can give a good example. We can give it just a civilian example too. Is if you think about just let's say a tornado hitting a school and you got kids in the basement that you're going into, you have other threats. So in that care under fire, that environmental threat that you're dealing with is potentially a secondary collapse. So you are entering a building that has collapsed. Right now, because it seems stable, doesn't mean it's going to remain stable. And so when being able to quickly reach that person, utilizing the people that you have available effectively, as long as they're trained to a level that they understand what's going on, picking the right person for the right job. So if I need somebody to go through with a sawzall, make quick cuts and make access to a patient that we know is in there, or the last known area that a patient was, I'm probably going to want my smaller, skinny spider monkey to be able to make his small cuts to go through there, be able to make access very quickly, while my bigger personnel may be behind, enlarging those openings, making sure everything is stabilized to the best that you can. A lot of times when you get into shoring a collapse, that's something that no one in SOCOM is going to really have available for them traditionally whatsoever, which means, people are opening up their books, they're cutting wood, they're hammering 16 penny nails into something that's going to hold up part of a structure. Like, that's not realistic. So in reality, even when you're doing hasty shoring, trying to make your way into it, you're thinking now, what is that building giving me? And I'm going to use pieces of that building to make the best option that I can based on what I have available right now. So understanding those principles allows you to call audibles, so where I'm not going to have the perfect thing, but I'm going to have something that can work the best that it possibly can to give me the best opportunity, the best chances for success, to be able to get that done and get in there. So in the end, you are under a threat, not just your casualty, but you are still under a threat too as a rescuer for secondary collapses, for ventilation problems, for all these other things. So in there, being able to quickly identify, and in a very confined space, limited movement area, be able to assess that patient the best that you can, prep them the best you can for packaging to get basically address those things that can kill them during your extraction out of that what they call an IDLH, an immediate danger to life and health, but that environmental pathology, and physically try and stop yourself at going too far. Just because once you start packaging them, and how many people are you going to get to be able to move that person through that area you just crawled through, right? Maybe two, right, at best. In there, typically it may just be one, depending on what your organic assets are. So in that, you want to, it is not an easy job. It's not an easy job. So in that, trying to maintain an IV line, maintaining a chest tube, maintaining somebody that for whatever reason you intubated, any of those things just is just an exponent to the time it's going to take you to get them out, because you're having to manage those things the whole time you're trying to move them. And a lot of times when you're, if you think about just moving a person that's on their back, even if you're in a soft litter like a foxtrot, let alone like a Skegco, which makes it very, very difficult in some of these areas. But if you're moving around a 90-degree corner where you can barely even get up on your knees and elbows to move them, just the positioning of having to get them to where their stomach is what's against that corner so you can bend their body, get them around that corner. I think kind of illustrates how difficult it is to maintain any kind of medical procedure that you did inside there. So being able to do those things that they kind of fall right in line with TC3 to a certain extent is very relevant, is to do the minimum that you can do. Apply a tourniquet, apply a junctional, be able to keep them on their left side as you're moving them out to hopefully, keep their airway going, or if they're vomiting and things like this. But getting much more detailed than that is really going to add a lot of time and expose them and you to a lot more risk while you're trying to get out. So yeah, and in the end, what you have available is going to be very different, for what your loadout is. And think about it this way too, is you can have a CSAR asset that can come up in with much more robust capabilities, but even within SOCOM, that has changed dramatically since the big footprint of Iraq and things like that, to where you have more integrated assets in there, and now it's on the individual units to have their own organic capability to conduct certain rescues, just because things have changed from that big footprint at one point where you had CSAR assets that were able to come in with more robust capabilities. Now it's kind of based on what you organically have available and using things off label, if you will, to be able to get that job done and be a little bit more cross-trained in your capabilities to be able to conduct hasty, immediate rescues, knowing the principles and then calling audibles based on what the environment gives you. So just like you and I talked about, if you're part of a recce team, besides medical, if you think about it from a medical standpoint, just understand that how it affects you medically is the same considerations need to be done from rescue. So what is that, 18 Delta, SOCOM medic, whatever, what does he change his med gear like if he's just on a recce team? Because now you're carrying food, you're carrying water, carrying comms gear, weapon systems, all those other things. So your med kind of shrinks and it becomes much more specific to what you potentially are going to run into compared to a direct action. And even on direct action, what's your infill? If you're on the X and your vehicles are right outside, you can leave a bunch of crap. You can load it kind of heavier, and it's available to you pretty quick, 20 feet outside the door, compared to if your infill was on a wire and it's an offset and you're coming in kilometers. Now things shrink quickly on what you're bringing into you compared to, are you doing a free fall? Are you doing something maritime? Are you doing something low signature? Is it Seaburn? All those things now play a role on what you have available and what you're going to bring with you. And I think the biggest thing is to understand those principles so you can make an informed decision on what you have and things that work in other environments, and look at your mobility packages. So if you look at mobility and you may have those high lift jacks, right? Those things are unbelievable for working structural collapse pieces, especially when you're have to do hasty rescues with somebody trapped, especially on an exterior wall or anything like that. You look at your high lift jack and you're like, there's no way that thing's going to lift, 15, 20,000 pound wall. No, it never does. It never needs to. You're just lifting part of it, you're cribbing it, and then you're lifting and then you're cribbing. And so you can use a lot of things that you probably already have within your mobility or your assault package and be able to use them off label to be able to create a very sustainable capability. When you look at that from training, you should not be bringing in a bunch of airbags and a bunch of other stuff. If you are part of the problem, and that's the big part, is if you're CSAR, you're responding in, right? Not unlike a fire department will get a call for a window washer or somebody that's fallen into a trench during construction or something like that. So you're responding into a problem, so you can bring that extra ass with you, that extra kit with you. But if you are part of that element, whether it's an assault or whether you're working, UW or something like that, you have what you have, and when something goes wrong, you're part of the problem. right? So you're not planning on being a response capability into that event. Rescue is, not your primary. It's not your secondary. It may be your tertiary or quaternary type of problem, but you need to have that capability when it arises. But the hard part is you're part of the problem. So a lot of things you're going to have to do is very, very hasty. So it's going to be outside that book of best practices, which is kind of a joke anyways.
Right. Well, I mean, usually guys will complain that, other units have much more money. Conventional forces complain about special operations that we have everything we want, which usually isn't the case. But even if you just knew the principles and you could figure out how to use what you do have so that, you can still be successful. But I think often we don't even attempt to practice. We just complain that we don't have the gear we need.
And that's really the key to success. I mean, just as a small example, you can look at people that are, whether you're doing an assault or you're a small, ODA rolling around or whatever the case may be, maybe working, lower signature type of stuff, is, you start looking at those things that you got to carry anyway. So whether that's maybe a high lift jack in your mobility package, but and I can't remember the name of them. I want to say they used to go by X Jack or whatever. You can go to Amazon and you see these things that guys in Moab use on their 4x4s and stuff like that are lift bags. They're high volume, low pressure lift bags, like the equivalent in rescue and the Casevac thing would be the cushions, the lift cushions, that you'll see your J's and some of your heavy breachers and stuff roll around with. But this thing actually just attaches to the exhaust of your vehicle. You put this flat bag underneath something and it lifts it up, and you can get it in 4-ton, 5-ton, whatever you want. But just that capability of how much training do you need to have to be able to put the end of it onto your exhaust of your vehicle, slide it under what you want to lift, grab whatever other pieces of broken building are around to crib the other side, and then just start hitting the accelerator. And it lifts 4 to 5 tons. That's a huge capability, especially if you're doing some sort of, immediate type of lift to free somebody up or to get some concrete off of somebody and things like that. Just understanding how to work levers is huge too. And a lot of those things can be done in tandem with one another without having any specialized rescue equipment whatsoever. And you can do some highly efficient, very, very quick rescues without having to learn everything within an airbag system or an air cushion system, which has its place, but doesn't need to be there all the time.
Right. Yeah, I would imagine that the specialized units they're doing this all the time, they have that gear because, they know exactly how to use it and it's making something safer or more efficient for them. But the occasional person, like myself, that's not my main job is rescue, but I found myself in situations where I needed to have that type of skill.
You're exactly right. And to go back onto the, just so you know, I don't get paid by any of these companies for saying things like high lift jack or X jacks and all this other junk, but just some of those things, we basically work off what groups organic assets, so that what's already going to be on the vehicles, what's already going to be there. And that's what we look at first before we even mention potentially bringing some other capability in that's out there. But a few years back, we were working with a group that was changing the way that they did vehicle extrication, and we were looking at traditional vehicles, unarmored vehicles, whether it's a Hilux, whether it's rental cars that you get, whatever that vehicle is, it's not armored. And we wanted to go side by side with Hamacho tools, right? Cutter, spreader type powered tools, battery powered, generator powered, all that type of stuff. And we just took a high lift jack. And in the end, we gave identical damage to each side of the vehicle and basically had some rescue specialists on one side using specialized gear that's in US SOCOM. And we took the other one and we just used a high lift jack. And I will caveat that it was a first responder high lift jack that has a little bit more capabilities than your standard high lift jack just because of the base and how it's rigged, but still extremely simple to use, right? You click the thing up or down depending on which direction you're going, and then you bring that lever out. Everybody pretty much knows how to use a high lift jack. There's not too much to it, so your sustainment on it is not really there. It's very simple to use. And we did 9 different vehicle extrication templates, the techniques to go from lifting a dashboard to TPing the back window to pulling a door, to even a pedal impingement where the pedals are entangling or going into your leg. And how can we do that? And so we just wanted to see much slower would we be with a high lift jack. So if we're looking at a pace type of thing, a primary, alternate, contingency, emergency, where would that high lift jack be? Would it be in that alternate, or maybe it would be in a contingency? Just because of its effectiveness, we might not be there. And after we got done doing it, and it took about 2.5 days of us taking times, looking at the techniques, and doing this, we never lost. The first responder was faster on every single technique than with the guys with the specialized rescue tools, the home mantras.
Huh.
So not everybody rolls around with a high lift jack, but we do know that it is in the mobility package for certain groups. And so if that's what you have, then learn how to use that. And it's about, that takes about maybe 1 day at the most to learn how to do almost everything you'd ever want to do doing vehicle extrication with a high lift jack.
Right.
And you probably aren't going to forget it.
Nope, that's for damn sure. You do it once. You'll in those type of situations, you'll remember that, how to do that forever, I bet.
Yeah.
You had mentioned earlier about the CASEVAC program.
So we're up on, I think they just put out for the RFI for companies interested in it. And so we're involved in doing some of the training, things like that with the previous version. I can't remember when that was. That must have been around 2010 or whatever, when the first CASEVAC came out. And what was interesting is there was some misreads in that occur quite a bit. This one just happened to be a SOCOM contract, right? It was officially named the TC3 soft CASEVAC program. And what was interesting about that is it combined a lot of the medical pieces in it that were pretty full spectrum, not just, for the assaulters, but went up through having, ventilators and oxygen generators and various somewhat modularized kits and things like that for the med piece. But the whole other half of it was rescue. And so in that, it had vertical capabilities. It had a little bit of stuff for collapse and confined. It had some stuff for vehicle rollovers, some vehicle extrication stuff in it. It even had some water rescue and things like that in it. So it was pretty robust on both sides. And when you look at it, there's a couple friction points that I think hopefully will be alleviated in the next go round. Is one, when it started, the statement of work started being written for it prior to, it was written in the big footprint days where you had CSAR, you had big footprints of various, organizations and SOCOM placed throughout, that huge workspace of Iraq and things like that. There were some delays in getting that contract out. And so by the time it finally came out and then got awarded, there was no big footprint anymore. So a lot of people saw it as, what in the hell, man? This is huge, fat equipment for people rolling in small groups in different places. And so the relevancy was somewhat lost a little bit because they did not make it really modular. The other side that they did is on the rescue side, they kind of made it a one-size-fits-all, which is not correct whatsoever. So when you look at it, the way that, let's say, Ranger Regiment and how they're rolling in their profile is going to be different than SEALs, which will be different than SF, which will be different than Special Missions Unit, which will be different than all these groups that are affected that fall under SOCOM. And having that one size fits all is not really awesome at all. So when you look at it, you're like, okay, I may need a haul kit. So now we're going to grab this 28-pound haul kit, which no one's going to carry. Why would you carry something that big on top of everything else if you're doing, an assault type thing? If you're not a dedicated CSAR asset, why would you carry something that big, that heavy? And as it turns out, a lot of people didn't, or they just kind of ransacked and took some equipment out of it and tried to make up their own stuff out of it, just because it wasn't modularized and it lacked the context of all the different groups that are within SOCOM. And one of the things that came out on it is one of the, hopefully they do not do this again, is under the requirements for the equipment that they put in there, they actually quoted NFPA 1983. And in that, they said that all the equipment has to meet NFPA 1983 or UIA and EN standard. And in that, those are two very, very different standards. And they have very different requirements, if you will. So when you look at NFPA 1983, what's interesting about that is that's a manufacturing standard. That's not an end user standard. That is so all the different rope companies, let's say, using vertical stuff as the example. So CMC and Sterling and PMI and New England Ropes, whoever is working together, that is actually the blueprint of how stuff gets tested if you want an NFPA stamp on your stuff. It tells you how big the lettering has to be. It tells you all these other things that mean nothing to you or I. In it, all it does is, and you don't even have to follow that if you're a rescue organization. And I think what US SOCOM missed on that one is going back that far, it was a different standard than it is now. Now the latest standard of 1983 is the 2017 edition. And if you look under the scope, and I always joke that no one reads these books, no one reads these guidelines typically unless you have enough Adderall, enough espresso and dip, and then you will. And that's kind of where I fall in. Is I will just read these things just to find out what it actually really says. And in chapter 1, in the scope of 1983, under section 1.1.5, I'll actually read it to you here if I can pull it up here. It says, this standard shall not specify requirements for any rope or associated equipment designed for mountain rescue, cave rescue, lead climbing, or where any other expected hazards and situations dictate other performance requirements. So to have that in something for SOCOM is, it probably got cut and pasted into that statement of work is just very negligent, right? Because you're now saying, listen, yeah, rescue that we do in SOCOM, it's not as dangerous as mountain rescue. And I think a lot of people would argue that. Anybody who's ever actually had to do rescue, not being me, I train people, but hearing stories back, I would say it's about 1,000 times more dangerous. And, typically in your typical mountain rescue or cave rescue, you don't have, people shooting at you, artillery coming in, ambushes, things like that, trying to get off the top of a rooftop very quickly when something occurred. So when you look at that, NFPA actually says don't use this, man. If your expected hazards and performance requirements are differ, please don't use this. And yet that's what they found in, which became somewhat of a constraint or almost handcuffs to the equipment that was brought in, especially for the vertical aspects, into the soft CASEVAC program because they included that. And when you look into it, I would say the last part of that is huge, or where expected hazards and situations dictate other performance requirements. So when you think about the performance requirements of SOCOM, they differ hugely from what you would ever see in a technical rescue in the civilian aspect. And I would say even the civilian guys probably miss a lot of the specificity or the context that they could actually veer off of this also. And so, just like what we said before, what are the performance parameters for the equipment if you're doing maritime operations? Probably really different. You're probably not going to want that nylon rope, right, which absorbs water. It's hydrophilic, so it's going to add weight. It actually gets weaker when it's exposed to water. Not good when it's salt water because it expands and now all the salt and the debris gets inside those fibers. So when it dries out and it regains its strength, you've got all the stuff in there messing with it. But it gets heavier. It doesn't meet any of the performance parameters really for almost any rescue, whether it's in the wet or it's dry. With nylon, it's kind of just your ghetto basic fiber for that. But in it, now you want to think about something else. Maybe we want to look at it like a Negra fiber, right, which is completely hydrophobic. It's the newest freaking high performance fiber that's out there, but it's also the lightest. So I love light. I'm old now, man. So I'm not wanting to carry heavier crap, let alone something that's sucking up water and adding to the weight of things. If you're thinking about chem bio, that's when you look at being around any of those things and you're doing anything in a vertical area, nylon, polyester, those type of things, that is not the fiber you want, man. Once again, go back to Negra, one of the few fibers that is very chem resistant, which is huge. I love reading the stats on a Negra and seeing like, oh, wow, 256 hours in hydrochloric acid, no loss of strength. That's pretty good. I like that, right? Those are different performance requirements, and those are things that SOCOM needs to be able to look at. Things that are in temperatures that suck and sand and all this other junk. That is, if you're in an area that you're making your friction, ad hoc. So you're using things like munter hitches and stuff like that to be able to lower casualties off a rooftop or even rappel it yourself. You're going to want something that at least has a sheath that is resistant to heat, right? Because you're lowering yourself, you're lowering a casualty, and to keep them from going 9.8 meters per second squared, you are adding friction. The byproduct of friction is heat. So having something that's an air emit sheath in there makes a lot of damn sense, especially when you're doing hasty. I'm getting somebody out of the hotel and I just do a 2-wrap over the balcony handle there, and I'm lowering somebody off of that, or I'm doing a munter hitch on my back. That's going to generate some heat. So that's not something I want a traditional fiber for, like nylon or polyester, really, So when you look at this, everything within US SOCOM, if you would just take that out, you actually just created this huge enabling capability where people can choose the right material with the right size diameter, with the right kit that they need, and be so damn safe. It's unbelievable. You're not compromising safety at all. It's just understanding that where nonlinear physics and material science meet up, you can have a huge capability and be extremely light, extremely fast, and extremely effective and safe.
But I mean, now that we're talking about it, I'm starting to, just because I also teach at the schoolhouse, I understand why they went to the NFPA, National Fire Protection Association, because they don't know anything about it either. Are there other associations that have a little more context to what we do?
Well, what I will tell you is this, we typically do most of our stuff off a UIA standard, right? So when you go to REI and you pick up a carabiner, whether it's Pestle, it's Rock Exotica, or whatever, there's a UIA EN standard on there. And that is relevant, probably a little bit more relevant to US SOCOM than necessarily saying 1983 for NFPA. With it, that's a mountaineering standard. And you can pull up UIA. And so what we use typically is, whether it's UIA or we use NFPA, if we're doing something and we're just curious, what's testing did it do to meet whatever requirement, we'll look at those testing. Well, what did it do for abrasion resistance? What did it do with X, Y, or Z? How did they break test these things? And that gives us a little guide into not necessarily what equipment we want to use, but what kind of standard we're kind of looking for in there. And when you get into 1983, as illustrated by 1.1.5, a lot of what's in SOCOM won't follow 1983, man. It's good because you can look at testing standards and then see what you're buying. If it's not NFPA, which it shouldn't be, stamped NFPA, then at least you can look at it and see that most of the things within climbing and other things go through rigorous testing, man. And so you're going to be very, very safe as long as you're not buying something that your buddy made in his backyard. Right. But if you're buying something with an EN or UIA stamp, you're going to be very, very, very safe, man. To say that doing urban rescue for fire department is not real rescue compared to doing a rescue in the Himalayas off a rock face, right? I think we're lying to ourselves. I actually would say the Himalayan one is way, way, way more dangerous, and you're doing it with much lighter equipment, and it's done every day without catastrophic failures whatsoever. And that's the other problem with when you get into civilian sides is we make huge advances in material sciences all the time, and to stay on top of that is nearly impossible. We work a ton with climbing teams, and material and innovation moves so fast that you have to stay on top of it. And it's dangerous a little bit too, because you can get some material that people fall in love with. They're like, oh my God, look at this Dyneema sling. This thing is incredible. The strength on it's unbelievable, blah, blah, blah. I can use it like I use anything. And that's not necessarily true. We use them at climbing. They're super strong, but they're very intolerant of heat. And so to think about moving that thing and making a friction hitch, so when you're rappelling, it's your backup for your rappel. So if you let go, you stop. That's not necessarily awesome at all. If that's all you have, there's ways of rigging it, but should not be your primary, just because as I'm rappelling down this rope for 200, 300 feet, and this Dyneema sling is going, it's in a friction hitch, which means it's seeing heat. And by the time it goes, you've got a melted piece of Dyneema, which will not hold you if you think that that's going to save you. So knowing its properties and knowing where it works and where it doesn't is vitally important. So when you get into looking at these standards, this is what is great about it is we follow and we teach NFPA operational qualifications. We do not follow NFPA 1983 because it's not an end user standard. It's actually a manufacturer standard we follow, when we look at what we want to do, we follow like NFPA 1006, which is the standard for technical rescue personnel professional qualifications. So even within the PJs, when they look at their guardian angel program and things like that, that's what they follow, is 1006. And what that tells you is what you need to do the job you intend on doing. So each chapter is a separate rescue discipline. So if you think about it, like chapter 5 is rope rescue, chapter 6 is structural collapse, chapter 7 is confined space, chapter 8 is vehicle rescue, and it goes on to chapter 22, right? And each one of those tells you what you need to be able to do individually or as a team to be able to be either an awareness level, operations level, or technician level. 99.999% of what we teach in SOCOM is always to the technician level. It's the highest level in there. But what's awesome about it is they never dictate what equipment you use, nor do they dictate what technique you use. So that's huge, right? So if you're teaching 1006 to a fire department, they may be using 12.5 millimeter rope. They may be using huge flat webbing slings. They may be using all this other stuff. But if we're teaching to SOCOM, we can do the exact same certification with whatever they're carrying, because it does not dictate or handcuff you to what technique or what equipment you have to use. So if you don't want a descent device and you're rocking a munter hitch for all your rappels, that's fine. If you had some new DARPA dental floss that met your safety factor to go on and put a human load on, dude, that's fine. So all they tell you is you have to be able to ascend rope, be able to descend rope, be able to set up a single point anchor, be able to set up a 2-point anchor, be able to set up a simple mechanical advantage, a compound mechanical advantage. But that's where it stops. It does not tell you have to do it with 11 millimeter rope, with a steel carabiner, with anything. It leaves it open for you, which is beautiful. So NFPA actually, in the operations for the end user, they never dictate what your safety factor is. They never dictate what equipment you have to use. And they don't dictate what technique you have to use, which is incredible. Most people just don't read in that far to realize that. They just think that all of a sudden this manufacturer standard is what you have to use for operational techniques. And that's not true one bit. The manufacturer standard is the manufacturer standard. When it comes time to do the other thing, when you're actually doing the work and you're rappelling and you're doing all these techniques to become a technician level rope guy or something, you can use whatever damn equipment you want, because it does not dictate what you have to use. What it does say is every group should have their own authority having jurisdiction. And this is where things, once people start understanding the standards that are out there, where the CASEVAC program and things like that, Guardian Angel, will have to adopt a new understanding or a new view of how they view rescue. Because the authority having jurisdiction, let's say you're training at the schoolhouse, and for whatever reason you now are including an 8-hour block of instruction for rope rescue. In it, the schoolhouse is who creates their own authority having jurisdiction. So you're your own entity. You decide, when we're training guys, what rope do we want to use? What safety factor do we want? Right? What equipment do we want? What carabiners do we want? It's on you. It's not, the NFPA ain't telling you, and they never will. And I love that they don't, right? Because who's to dictate who's a mountain rescue team that may have to hike in miles of rough terrain to even get to a casualty and then get them out, compared to an urban team where your trucks are down there and they can carry 80-pound backpacks all day up because you got, 18, 20, 30 guys responding to it. Right. And so in it, that's where the confusion hits on is it's the authority having jurisdiction. We do a lot of training, regardless of organizations, within, let's say, USASOC, but you can have, one organization alone, you may have 16 different authority having jurisdiction that all have different requirements on what equipment they use and things like this at the same place. If you're talking Ranger Regiment, they very well could have different ones for every battalion, and then even break down to even smaller individual teams on, depending on your recce team versus this team versus that team. All of them can have their own authority having jurisdiction and dictate what safety factor they want to follow, what equipment that they want to utilize. And that's fine. You're meeting NFPA standard by that. And when you read NFPA, that's all it says is, being able to use the gear that has been given the thumbs up from your authority having jurisdiction. And your authority having jurisdiction can be one guy, it can be two guys, it can be a team of 5 or 6 guys that all say, hey, we're the group, and we're going to kind of dictate what carabiners are going to be bought and issued out. Not unlike stuff within TC3, man. You know, what hemostatic are you using? What tourniquet are you using? What thing? And it's somewhat similar. You make that your mind up, and you do it on an educated guess, and you are following the standard exactly. There is not one thing that NFPA tells you that you have to carry or a technique you have to do. It's on you, man. But one thing that I would tell people as they approach into the CASEVAC, the one problem that we did see is all the medical gear that goes into that is got to be into the current TC3 guidelines, right? Which is good, right? Which is great. It provides some sort of, I don't know, maybe standardization, things like that for the kit that's in that program, which is absolutely necessary. What I would tell any of your listeners is be very, very cautious. And next time you're out doing some rope stuff, or you're doing some confined space stuff or collapse stuff, start utilizing more of that kit into the rescues. Don't just do the rescue, do the rescues with the kit in there. And what you're going to find is problems that aren't looked, because although it's in the TC3 guidelines, it has never been tested in the area of rescue. And some weird things can occur in there. And so one example is the junctional tourniquet. So as it stands right now, every junctional tourniquet that's recommended fails about, and I would say 100%, because I'm really saying 100%, but we'll just go ahead in that 90% plus time of, they will fail 90+% of the time when you're doing a rescue, whether that is putting it on somebody in a vehicle and then manipulating the body out of that vehicle, whether it is in confined space or whether it's in a vertical situation, those junctionals will fail. And what sucks is there are some that haven't. The latest version, the newest version of the AHAT actually has been the best for us in rescue, and it makes sense. Why is that? And this is the new version that no longer has the windlass on it and stuff. And so if you haven't seen it, you can throw it up at AHAT, or I think NAR, North American is carrying it now too, is with it, it's out of the way. So I've got to bend you a lot. Where do you bend, man? You bend usually where junctionals go, man. And so by doing that, we displace those things or break them during almost all the rescue stuff that we do. The AHAT is a little bit further up, and although people have some issues with it and stuff like that, I do know some higher level units that's all they carry for good reason. And I can tell you, like, we've not had one since they redid it. We have not had one fail in any of the rescue stuff that we did. So I would start looking at the stuff that you have to do medical and start putting it into your medical scenarios and trying to make it fail, man. Seeing where it will fail. At least, even if you don't get any new kit or there's not a substitute for it, at least you know where you can expect that thing to fail or where problematic issues arise from it, which is huge, because since it became the TC3 soft CASEVAC, you have all this TC3 kit, but half that contract is rescue. So start looking at your medical stuff when you're doing a rescue. And I think that becomes very critical, and you're going to see different ways that you can do it, even when you're able to get that tourniquet on, right when you have that tourniquets, whether you're looking at the CAT or soft T, I like just having a little bit of duct tape or whatever, and I'll put that over that windlass and lock it in a little bit more, just because of it could just as easily be you that tears the Velcro and puts your knee on the windlass a little bit and undoes the tourniquet halfway through your rescue, and you won't even know it. So being able to secure those things that you normally don't have to in regular situations, when you're crawling all over people and trying to manipulate people to get them out a window or off a rooftop or off over a parapet to lower them down, things become different, man. It's a different context. So I would definitely tell people, train on that stuff, put it in there, and try and make it fail, man. That's HRO, right? That right off the bat. I don't care if it worked 1,000 times. It's that one time it doesn't work that I want to be aware of when that possibility occurs. So have a preoccupational fail. Everything can fail at any time, right? So being able to train hard enough in full mission profiles and things like that, so at least even if there isn't a replacement, at least you know what you can do or where you can suspect that a piece of medical gear will fail you during a rescue. What else do I have here? Boom, 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 boom. Safety factors we talked about. One thing I always tell people is once they go vertical and you're a couple hundred feet off the ground and you're lowering your casualty or you're rappelling in, we see people start taking a mindset of like, oh God, this is out of my norm a little bit. So I want to back up on a backup on a backup. And eventually adding too many safeties in, you'll see more accidents because you've just created complexity into something that should remain somewhat simple on your rescue thing by adding extra in the name of safety. We actually decrease safety at a tipping point sometimes. So be cautious of that. But the other side is make sure that your rescue techniques that you do fall in line with how you roll normally, right? You shouldn't be this predator freaking fast roping in and just raising hell and making things happen and just going crazy on an OODA loop, man. And then all of a sudden when it comes time to do a rescue or do something vertical, now all of a sudden you turn into this like slow, methodical prey type of thing. Many of the things when you build a system, whether it's for vertical or anything, can be done very simple, very quick, and very safe. And I always tell people, I'm like, what is your safety factor when you're fast roping in? Don't let go, man. That's your safety factor, dude, right? I mean, you're doing a 60, 90-foot fast rope, like, yeah, I really want to keep my hands and my feet here, right? I before I go off, I got both my hands on, I got one foot on, I have 3 points of contact, I go over the edge, and I add my, my fourth point on, and I try and maintain my safety there. At no point are you just like, I'm going to let go. That's your backup, right? That's your safety when you're doing that. So think about that, right? So before you get kooky on adding 100 backups into doing a simple rappel off a building that's 50 feet up, think about, do I really need all this, or can I manage and understand the system as a whole? So I understand this is where my break is. This is how I can go. This is how I can slow myself down, and keep it simple, and don't go overboard because you're not falling into the flow of your natural assault as it is. And there's ways around that where you can stay really safe and not be using belay lines and all this other junk that just gets in the way that you'll never use operationally anyways. So it's something to think about on that too. We already talked about that, but in the end, also look at what you have available. Kind of going back to the high lift jack, there's a guy who's a good friend of mine who was killed October 22nd, 2015, named Master Sergeant Joshua Wheeler. And one of the trainings we did prior to his death was he was doing some other stuff and didn't want to carry a rope bag. He was a team leader of a vertical team, of a climbing team. And in the end, middle of a class, he's just like pulled up his webbing. He's like, hey, dude, like, what can we do with just our webbing? And we just started getting thinking, and we're like, well, we know it's strong enough, right? Even mil-spec webbing is 4,000 pounds end to end. Once we tie a knot in it, we know we're losing some strength. But how can we combine my 22 feet of webbing with your 22 feet of webbing, with his 22 feet of webbing? And now we got a capability to potentially get ourselves off of a building in emergency, like an emergency egress, or we can get a casualty down very quickly just by us tying our webbing together in a specific way and having a pear-shaped carabiner. And, just from that one class that he brought that up, we're just like, all right, let's just stop the class and let's just figure this out over the next couple of hours. And that's what we did. We tried a bunch of different knots. We saw which knot would make it so you wouldn't have to pass a knot on a rappel, that it would just flip through your carabiner. And it took us about an hour and a half to create an entire new TTP on utilizing webbing instead of rope, man. And with that being said, if you got guys out there listening that don't carry webbing, I would tell you, man, like, everybody on your team should have 20 to 22 feet of webbing all the time. And this should be like your IFAC, right? Just like how you have guys having an IFAC, that should be part of your IFAC, because with that 22 feet of webbing, I can now combine it with yours and his and whatever, and I can get off an 8-story building very, very smooth, very easily. I can lower a casualty off a building very, very easily. And on top of that, I can tie it I used a frost knot, right? Very easy to tie. And I can put that in and create a loop, and I can create a way in which we can now create a harness to lower him or a harness to carry him. And so now that becomes my drag capability. So as you move in through the IFAC, you can grab his 22 feet of webbing and use that on him to be able to drag him, to be able to throw him over an edge, to be able to lower him with more webbing, man, that you already carry without having to bring in extra rope stuff. So you just need your own personal webbing and a pear-shaped carabiner, man. And you can conduct quite a bit of rescue if it requires you getting out off of a building, whether it's a casualty or you. So don't handcuff yourself thinking, oh, I gotta have rope. I gotta have an entire elaborate rope system or something like that. You probably don't, man, and you can probably use what you have naturally available to you too. And we've got videos on how to tie that stuff together and stuff like that. It's super, super easy, and it's very safe. And we've been doing it ever since that one class with Josh. And it was just one of those things where he just didn't want to carry, an exo system or whatever rope they were carrying at that time. And he's like, what can I do with just this? And it turns out you can do a ton with just that. And so the whole point is democratize rescue. Make it so rescue isn't for just rescue specialists, man. Be able to do some easy rescue. TC3 democratized medicine, man, right? It made all the warfighters less reliant on having a medic right there. It's not the medic has to put the tourniquet on. It's not the medic that has to, decompress the chest or put a chest seal on or roll them into a recovery position or put an MPA in or whatever the hell you're doing. You have these IFACs that now you've democratized medicine to the non-medical guy. And we can do the same thing with a lot of hasty rescue techniques to where you're not relying on that one guy who went through that rope collapse or this and that. Dude, being able to tie your webbing together and be able to flip it through your carabiner in a 3-wrap and how to pass that knot when you go, dude, you can learn that thing in probably less than an hour, and now you've got a capability that's huge.
Outstanding. Where can I get more resources on rescue?
You can hit up. We kind of have a knowledge management library that we do, so on Element Rescue, you can hit Element Rescue. We've got a whole page of podcasts. The Andy Schrader ones you talked about were on there, but we do a lot of things as far as demystifying NFPA and taking the time to read a bunch of boring ass crap so you don't have to. But we always works cited, so don't believe what comes out of my pie hole. We'll give you the references to be able to look it up yourself, because even within the fire service, you brief the stuff that we've even talked about, and they will be like, they will call you a liar. That is not true until they look it up and they're like, holy crap. And, I always joke that like the fire service and really even rope rescue to a certain extent is second only to the Catholic Church and tradition, man. And so why do you do that? Nah, it's the way I learned. That's the way my instructor learned. That's the way we're going to keep doing it. And it's probably not always the best way at all. And so we have a lot of the reference points, the papers. I always joke that we're kind of about 5 to 8 years into what I would call, as far as rope rescue goes, it's kind of the rescue revolution, or it's a new era where all of a sudden all those things that have been printed in books and taught in classes for all these years has actually been tested for once. So it's all this theoretical stuff for so many years. It's this dogma that's lived on. And all of a sudden, thank goodness, there's some really smart people out there that happen to have PhDs or do research professionally for, Booz Allen and all these crazy places that happen to be part-time rescue guys on volunteer teams. And when they are told, hey, this is the way you have to do an anchor, they're like, where's the data for that? And they're not finding any data. And so they're like, hey, I do research. And they'll get all these companies to donate webbing and stuff, and then they'll, basically do a UFC match where, 2 anchors go in and 1 comes out, and actually evaluate it. And through the past 8 years, everything from webbing anchors to Prusix to you name it, all these things that we've been taught for so many years has turned out to be completely false, because no one actually did the testing originally that made it into books and made it into the dogma over the last 30 years. And so now all of a sudden, all these smart people are doing testing. We're fortunate enough to work with some of them to where we're like, hey, why don't we check out this? What about knot strength? Let's talk about this. Let's talk about that. And all of a sudden, all these things. So we post all that data on our website, so you can pull it up and go disrupt your administrators or the old salty guys that believe there's only one way of doing it. So Element Rescue has a bunch of that stuff on there. I know North American Rescue, we've been helping them just because there's such a huge entity out there and a leader and innovation, and a lot of people go in there. So they're actually building up an entire part of their website now with a lot of that information. And so I think where you're going to see that organization go, which I'm pretty excited about, is they're taking a role as they are going to cater to those people, which are pretty much most people that are probably listening to your podcast, that fall under that 1.1.5, where your performance requirements dictate another means of doing things, and which is really what TC3 was, right? TC3 was never made for the traditional ambulance guy. It was made for people that work in an environment that their hazards and their situations dictate other performance parameters. And that's what they're kind of doing with the rescue side, which I think is pretty exciting, because it would take a name like that to be able to get that information out. So they'll be having quite a bit of stuff on their website, so look for that. We're helping them with some of that too. Element Rescue has a bunch of that stuff on there too. And what I would tell you is democratize rescue, make it easy, take all those friction points of why you never want to learn rescue because you think it's complicated. It's not, man. It's not at all. It's very easy. It's very principle based. And once you understand a few things, those carry over. What you learn in rope will carry over into confined. What you learn in confined will carry over into structural. And what you'll find is you'll kind of look back and be like, dude, this is actually not that hard, especially if I use simple techniques and keep it as simple as possible. I think it was Einstein that says, make things as simple as you can, but not any further. And you don't want to remove the complexity that already exists, but you definitely don't want to have to learn 18 knots for no reason whatsoever. And most of them do the exact same thing as another one.
Right. Well, outstanding. Hey, thank you, Sean.
You bet, man. I appreciate your time.
That's it for today's podcast. Be sure to go to our website, www.prolongedfieldcare.org. Find us on Facebook, YouTube, Instagram. Subscribe and stay on the bleeding edge of combat medicine. This is Dennis for the PFC Podcast. Out.
Boy, it's waiting there for you.